OK, hi, everyone. I see people are still coming in, but I think we can begin because we have a lot of stuff to cover. So maybe we can do introductions as people still join. My name is Alina. I'm very happy to be here. This is my first time at DevBcn. I've heard many nice things about the conference from my friends, and I'm happy to finally be here, especially on this anniversary. It's a great honor to be here and speak here with you. And in this session, we will talk about 5 cool applications that you can build with GraalVM, and not just GraalVM, but specifically with native image. So this ahead-of-time compilation part of GraalVM. And normally, I like doing sessions where we go a lot into details, like technical depths, talking about performance optimizations, library configuration. But maybe this one today can be a nice, chill session where we just will build 5 cool apps and see them working and see how versatile GraalVM is. Before I begin, how many of you have heard about GraalVM? Most of the room, give or take. And how many have tried building something with GraalVM? Roughly half, I would say. OK, maybe I can convince at least a couple more people as this session goes on. Super quickly about me. So my name is Alina. I work at Oracle on GraalVM, and I care a lot about communities and open source. That's why I like coming to places like here. I also love languages, both programming languages and natural languages. I'll be honest with you, Spanish is one of my favorite ones. I studied for a couple of years. I don't remember much of it now, but it's definitely one of the most beautiful languages in my book. And about what we will build today, so there are many cool things you can build with GraalVM and native image specifically, but we will focus on those things. And I think we will have to choose towards the end, because I think we will run out of time. So maybe in the end, we can vote for what is more interesting for you guys to see. But the plan is to cover a CLI application, a fully blown full-stack application, a DIY LLM inference engine that you can yourself create at home, talk about performance optimizations, and then security, and if we get to it, a polyglot application that combines Java and Python in one app. So let's go, and a very quick refresher, because sometimes people get lost in terminology and what is GraalVM and what isn't, because there have been many talks and blog posts and demos about GraalVM around, so sometimes it is confusing. GraalVM is many things, but 3 kind of main things that you need to remember about it are the following. First of all, it is a JDK, so you can use GraalVM as your JDK and just run your Java programs on GraalVM as a JVM, and it will just have a better, different JIT compiler. Also, it has this pretty brand new and groundbreaking ahead-of-time capability, where you can compile the application ahead of time into a native executable, and then you can deploy it and run it on a machine that doesn't have Java, but it will just run as a native program. So you still write it in Java, but at runtime, it runs as a native application. And then last part here is that you can also use all those other languages on GraalVM, either to run each one of those or combine them all in one big polyglot program. So sometimes when I go to conferences, people ask me this sort of tricky question, which is, when should I not use GraalVM, trying to get me to say, what is a bad use case for GraalVM? And there I always say, always use GraalVM. There is no reason not to. Just choose for yourself which part of GraalVM works best for you. And let's talk about native image. So again, this session will be focused not on the JIT part and not so much on the polyglot capabilities, but specifically on the native image compilation. So native image is a part of GraalVM that lets you take your application as it is Java and compile it ahead of time as you're still building your application into a native executable. So you write it in Java, then you compile it, and as the output, you have a platform-specific native executable. So let's say I'm a Mac user, I get an executable for Mac that can run without a JVM as a fully native program. And the idea there is to move all of that kind of infrastructure overhead work that the JVM normally does when you start your application, only maybe you don't notice it because it's kind of hidden from you in other threads, etc. So the idea is to move all that work around class loading, interpreting, profiling to build time, and do it once instead of doing it every time when your application starts. So to do the same thing that the JVM does every time at runtime, but do it once when you build your application. And this needs to happen under closed world assumption. This is important to know. So everything there is to know about your application, all the classes, all the libraries, all the configuration, needs to be known at build time. So if you are maybe new to GraalVM, you might be wondering why would you do this, what are the benefits? And one clear benefit is that application built as a native image will start much faster. So if you have started an application on the JVM, especially maybe a bigger sort of enterprisey app, you do know this kind of warming up curve on the JVM, where it takes a while to start because it needs to understand what your application does, pull everything together, discover your classes, dependencies, framework, etc. And then eventually it warms up and it can run with good peak performance. Now, with native image, that startup is almost instantaneous because we did all that work at build time, so when you're compiling your application. Another benefit, and you might tell me, OK, I don't care about startup because let's say I have an application, I deploy it, and then it runs for, I don't know, days or weeks. The startup doesn't matter to me, right? In that case, you might be wondering about the resources usage, and namely CPU and memory, because we also use less memory and CPU because there are fewer things for us to do at runtime. So again, we have built and compiled everything at build time. At runtime, we just start, and it starts very fast as a native program. Along with it, it also has predictable performance. So if you were to imagine the performance of a native executable, let's say, as a line that shows, let's say, requests per second, it will be very stable over time because all that work has been done already at build time. And there are more benefits that we can talk about, but I would like to switch to demos because there are a lot of demos that I want to show to you, and I only have 50 minutes today. So the first application that we will build will be a CLI application. So let's say you want to build some sort of CLI application that does some maybe routine sort of work for you and acts as your little assistant. There are nice frameworks and also multiple ways to do it with GraalVM. Namely, there is a very cool framework, maybe you know about it, PicoCLI. Anyone in the room? My friends, yes. So you can use PicoCLI, and then you get to use many frameworks and get to make your own choice. Another thing that I can endorse, and I have tried out and I want to show to you, is to use the Spring Shell module from the Spring framework. So let's take a look at that. So this is our application. And on the surface and under the hood, it's a pretty normal Spring application. If you want to build those sort of CLI apps with Spring, they give you a lot of things from out of the box, so from the framework. Here, we are just annotating our application, describing that this will be a shell application, and our application will be called Qt-ls. So this is a more cute version of LX, the standard Linux sort of list my files, list my directories command. And the way this is implemented in Spring, I just need to add my class, add my methods, and annotate with the components to tell Spring that this will be a shell application. And then we will list our current files, and hopefully our output will be more cute than your normal ls. So let's take it for a spin. I already have it compiled here. It's called native Spring Shell, and it's 40 megabytes. It could have been smaller if I wanted to optimize it even further, but honestly, I don't care for the sake of this demo. So let's start it. Target native Spring Shell. One small detail that I would like to point out here, it's not very important, but I think it's kind of interesting. If you were ever wondering how you can add your own custom banner to, let's say, Spring application, apparently it's very easy. You just need to drop your banner in this sort of ASCII art format under source main resources, and then the framework will automatically pick it up, and this can print out your project name, your colleague's name, your colleague's, I don't know, photo, anything. I think this is super cute. But let's see what our application does. So we can retrieve help, and then there are some built-in commands that come to us from the framework, so things like history, help, quit, etc. we don't need to implement. This is available already, and then this Qt-ls is the method that we have implemented ourselves, so let's try it. And I think we can all agree that this is at least more cute than the normal Linux ls command, right? And it can also take arguments, so we can look what's inside our target directory. And it looks very nice. It can retrieve history, etc. And it works, as you can tell, very, very fast. So this is a CLI app. I don't think you can notice that much of a difference there, but you will when we build bigger applications. So this is one application that you could have built with GraalVM and either PicoCLI or, in this case, Spring Shell. Now, next, let's talk about something a bit more meaningful, maybe something that you can potentially build at work. So at work, chances are you are working on something a bit more kind of serious, commercial. Maybe you need to have some sort of full-stack application where you have your backend, you have your front end, And ideally, I think you want, first of all, your front end to look nice and decent and kind of professional, but also you still want the application to start fast, to use fewer resources, and in this case, also have good peak performance. And again, all those benefits we can get from GraalVM as well. Now, there are multiple ways to do this and make it compatible and compile it with GraalVM. There are also several kind of frameworks and projects that you can use. I want to, again, give a notable mention to JHipster, but the demo that I will show to you will be this Viadin project that lets you very easily build full-stack applications. And there are links here. You can afterwards access the demos and the projects that I have mentioned. And this next demo that I will show to you, it came out to be when I first wanted to build this sort of travel application with GraalVM. And I built it, and it was perfectly working using OpenAI API and giving us travel recommendations. But Markus Hellberg from the Viadin team saw that front end that I have created myself, and I'm clearly not a front end person. So he was mildly shocked, and he went away, and he recreated this with Viadin. So now our application also has a nice front end. And for the sake of saving time, we already have this application, again, compiled as a native image. This one is significantly larger, but what is interesting here, it bundles everything inside the app. So in our project, if we super quickly take a look, we have our Java backend. Then we have front-end that is sort of generated for us by Viadin, but we still write our front-end logic in Java. And then this little bundle here contains my entire backend and front-end all in this one file. So let's start it. Now, this starts a bit longer than I think it could have been, but it's not fully optimized. And also, again, I think for a fully compiled full-stack application, it is still pretty decent. This startup, it's not so bad. And it's a travel recommendation app. It looks something like this. So again, also doesn't look too sophisticated, but we can all agree that this is much better than anything I could have wrote manually with HTML, CSS, and JS. And it's a travel recommendation application that will use OpenAI to generate recommendations for us. And hopefully, we will see that it's working as expected, but also it also works pretty fast. So let's say we want to travel to Barcelona. And we need to choose some activities, things that we want to do. So I, for example, like reading books. So maybe we want to get recommendations for books. Any other things we would like to do in this city? Pancakes. Love it. Cakes. Cakes. OK, more. I cannot type. OK, more preferences. What to do here? What? I don't hear you. OK, let's do something else. Beach. And we need to choose a mood. So let's say we are feeling happy. So now this will go and put a request to OpenAI API and come back to us with some recommendations. So apparently, Barcelona has a very rich literary history. If you're a fan of pancakes, I don't think churros would count as pancake. I don't think this is entirely true. And for the beaches, I think we can all agree that indeed this is something Barcelona is famous for. So I think we can say our application is working. It is legit. We can rely on it. And again, it all works super fast because it is built on GraalVM and native image. So that was our full-stack application. But as I mentioned, there we are calling the OpenAI API. And even though OpenAI gives us very good models, it is a cloud-based LLM. So you might have concerns around privacy, or maybe you don't want to pay for it. So what about using some local LLMs? If you have been like me previously today in Alex's session, he talked about running models locally with Ollama. But I would like to show you one more way to run kind of LLM engines locally that my colleague has built. And this is an LLM inference engine built in pure Java. So it's kind of hard to explain, but stay with me here. So what we have here, I can quickly show you. Let's first look at the files. So what we have in our project directory is just this one llama3.java file. So the entire project is just one Java source file where our logic is defined. And then we have a model from places like Hugging Face, where you can get any model that you like. So you really can choose bigger, smaller, different sort of names of models, et cetera. And the project looks like this, where all the logic around inference is focused in this one Java source file. So there is not even like POM.xml or anything. It's just one source file, which is not so big. And this is what defines our inference logic. So what is inference logic? It's the logic that, along with a model file, gives you a complete local engine. And in a way, it defines your message format, your prompting strategy, your sampling strategy. So other than the model itself that contains the weights, all the other logic around predicting and sort of giving the answer and the next token to your user, all of that is defined in pure Java. So there are, let me just scroll up, there are no even imports of third-party libraries, nothing like that here. And this is not necessarily something to replace OpenAI, but I find it a really cool kind of hobby project that you can use to run your LLM assistant locally with zero effort. I don't think it gets easier than just running one Java source file and supplying a model. And also, it shows us how powerful and versatile the Java platform is. Because, again, this is no Python, no C, no anything. All the logic is implemented in Java. And this is possible because Java now gives us great APIs to work with such sort of LLM ML workloads. Namely, here we are using the vector API because we want to have very fast computations. And we are also using the FFM API because we want to have a way to work with this large model file in a very fast manner. So again, all the logic around interacting with the user is implemented in Java. And let's take it for a spin. So it's implemented in Java, but of course, I already compiled it as a native image, and we have our native executable here. So we can just run it again as a native program. And the way to run this will be to start the native program. Then we need to supply a model. And here we have Llama 3.2, 1 billion parameters. 1 billion sounds like a lot, but honestly, it's a very small model because we want our assistant to be very fast. And then we can chat with it. What did we do wrong? Model. Let's run. OK, let's try. OK, I always fall for that one because it's not full screen. Thanks. Llama 3.2. Now we're on. Thank you. So we can do hello. We get some warnings, but it's all fine. And then we can ask it what it is. What are you? And it will say that I'm an AI known as Llama. I'm developed by Meta AI, etc. And again, this is running fully locally on this poor old Apple M1 first-generation machine. And I think we can agree that it runs pretty fast. And if you are a lucky owner of something like M3 Pro, M4 Pro, it would have been much faster. But we can ask it something more fun. My friends here know that I'm very motivated by food, so maybe we can ask it some food recs. What should I eat in Barcelona? It is a food lover's paradise. I think it is true, and it's not my first time in this city, and I think it is a paradise for someone who loves food. And it goes on and on about giving us some good recommendations for both like meals, desserts, etc. But the bottom line here, I think you can agree that this is a decent way to run local LLMs easily on your own machine. Maybe you are traveling. Maybe you don't want to access any cloud LLMs. Maybe primarily you want something for a kind of quick development and testing, and you don't want to pay for any of those cloud LLMs. So I think this could be a nice way to have your LLM running for you locally just on your own machine, or maybe for development and testing. And I think it's pretty fun. Also, if you happen to be, I don't know, maybe some of you are teaching kids at school, at university, etc. This project is also heavily commented. So if you want to kind of teach your students about LLMs and also Java as a platform, this is something that you can use as your sort of educational material and show that there are many, many different kinds of applications that can be possibly built and run with Java and also with GraalVM. Now, if you happen to work in the industry, you will want to know what about peak performance. So we all know and love JVM for peak performance. And sometimes, again, coming to conferences, people ask me, OK, I tried GraalVM. It seems great for fast startup, low memory usage. Packaging is very small. It's all very good. But what about peak performance? Like we all know that the JVM is very fast. It's very good at realizing what parts of our application are hot and what needs to be optimized. And sometimes people will even go as far as to say that AUT compiled code will never be as fast as the code running on the JVM, because JVM looks at the application as it runs. It can optimize, it can de-optimize, and there is no way on earth an AUT app can build a just-in-time running and compiling application. For that, we will do some quick and dirty benchmarking. By no means it will not be like fully professional benchmarking, because that will take hours and hours. But as much as I can fit into a conference session, we will try to do some benchmarking now. Let me just close this. OK. So what we will benchmark here will be the Spring Pet Clinic application, which is commonly used to benchmark applications in the Spring space, but also the wider Java space. And it sort of emulates an application that could be running at a pet clinic, so a veterinarian's office, where you can read and write data, schedule visits for your pets, get information about doctors. So it's a very good kind of representative of a typical sort of enterprise workload where you want to have something resembling what you could be running at work in production. And our benchmarking setup, I'm quite proud of it because it's quite extensive, so it will look the following. First, we will benchmark the C2 JIT, and C2 is your standard top-tier optimizing compiler in, let's say, OpenJDK. So when you download Java, most likely that is the JIT compiler that you get. And our benchmark would look like so. First we will start our application, and I only have different flavors of GraalVM installed on my machine. I don't even have any sort of OpenJDK. So we will use GraalVM as C2, but we are turning off the Graal compiler, so this effectively gives me back my OpenJDK setup. And this is also a nice thing to remember about GraalVM, that we never remove anything from the JDK, we just add things on top. So if you have GraalVM on your machine, you still have your OpenJDK, just with extra modules and kind of extra features. So we will start our application. Then for 10 seconds, we will just wait and let it a chance to properly start. So we are not even warming up. We are not benchmarking. We are just giving the JVM a chance to start, load everything it needs to load, and kind of prepare for the benchmark. Then for 10 seconds, we will warm it up. So we will send requests, but we will not look at those numbers yet. We will just use this as a warming up opportunity to be fair to the JVM. So give it a chance to start and warm up. And then for 20 more seconds, we will actually benchmark after we had a chance to properly start up and warm up. So this takes a while. This setup takes 40 seconds, but this is probably the closest that you can get to reasonable benchmarking at a conference session. So let's go. And as this runs, I also want to talk about what are the actual requests that we are sending. So this is the folder. And requests are defined in this Lua script. So again, instead of starting the application and just bombing one main entry point with a million requests, what we are trying to do is we are trying to access different endpoints and also both read and write data. So that is to show that I'm not overly optimizing for a specific kind of runtime, but rather trying to emulate what a normal human being could have been doing. So for example, here we are creating an owner, then we are adding a pet to that owner, then we are reading the info on the owners, again, creating a visit for the owner, for the pet, so trying to emulate almost a normal human being. And as I was talking, the benchmark is finished. So again, this is the JVM, this sort of OpenJDK kind of setup, right? And I see two immediate things here. One is it is all run, all good. Second, I do see that there is some sort of warm-up curve. So the results that we want to look at, here this is the warming up round, and here we are at 500 requests per second. But after the application has warmed up, we arrive at 1.4, so almost 3 times the throughput. And I think we can all agree that this is pretty standard for what I do. OK, nobody's breathing until the end of the talk. It does warm up, and then it arrives at 3x the throughput of our warming up round. So in the end, we have 1.4K requests per second. So is this fast? What do you guys think? Somebody is skeptical. I'm with you, sir. I like your optimism. OK. But I think, in general, it's kind of hard to say unless we have a sort of reference point and something to compare it with. So let's run the same benchmark, but on native image. So again, this was JIT, right? And for native image, we have a similar setup, only this will be bench native. And here we have the exact same things because we want to be able to compare side by side. So we need to have the exact same methodology. Only here we are starting the native program. And then in the end, we will be looking at the charts. We will see that those 10 seconds here are just wasted because the native application doesn't need to warm up, right? We talked that we did all of that warming up work when we were compiling the application. But just to be fair, and just so we can compare across the setups, we are also waiting 10 seconds here. Let's go. Native. OK, and this will take another 40 seconds. OK, so who thinks this will be faster than the JVM? Some people, but also, again, those who are already in this talk. OK, let's see. It's warming up. The warming up results came, but then we will need to wait for the proper kind of final round of benchmarking. We can see that even the warming up round, I would say it's not bad. It's 1.1K. But here we will see that the native program doesn't warm up. It's very fast, but it's stable over time, sort of how I promised in the beginning. So it finished. And as we see, indeed, the performance is very stable over time, but it is a bit less than the JVM, right? So here we are at 1.1 as opposed to 1.4. And here I can say that, guys, it's very hard to do good peak performance if you're building ahead of time. We don't have the exact same information that the JVM has. We don't have the profiles. We cannot de-optimize. And the JVM is an amazing piece of engineering. It's very hard to beat it at its own game. So while all of that is true, I think we can do one more thing here. And one more thing here is that I also have one more version of this benchmark where we have something called native optimized. And this is also a native program, but built with a few additional optimizations in place. Let's quickly look at those. So if you want to have a sort of the production deployment of GraalVM and natively compiled application, and you want to make sure that you also have good peak performance, what are the steps that you can take? First of all, the most powerful thing that you can do is called profile-guided optimizations, PGO. And that is, if you know how the JVM profiles your code, is it looks at your program as it runs, and then it looks at which methods, loops, etc. are most often executed. And then it compiles those to the machine code, because those are sort of performance-critical parts of your program. But that information is gathered as your application runs. So technically, for us, we cannot know what will happen, because the runtime hasn't happened yet, right? We operate at this build step. But what you can do is PGO, and that is you can do this two-step process where you are building an instrumented version of your application, run it, apply a relevant workload, and then when you shut down your application, we will create a profile file of your application that will tell us, when you next compile your application, what happened at runtime and which parts of your application were warm. So this way, we can gain sort of an insight what happens at runtime. We can know exactly which parts of the application will be warm and where it makes sense to spend most of those compilation efforts. So you sort of give us a way to look into the future and see what we need to optimize. But this requires a two-step process where you first build an instrumented version of your application, and then you compile again with those profiles in place. And it's not always that you want to do those two steps, or maybe it's not always that you have a really performance-critical application. But is there something easier that you can do if you cannot be bothered with this two-step process? So you would think that in 2025, in the age of AI and ML, there could be a sort of ML model that could help us. And we thought the same thing. So now we are shipping a tiny little ML model in native image that, as you build your application with just one step, it will look at your application and it will try to predict which parts of the application will be warm. And this will not be as precise as you actually running the application and letting us a chance to see what actually happened. But this is the next best thing, comparing to not having any of this information at all. So if you cannot be bothered with what we call user-provided PGO, you can do ML-enabled PGO, and there you can win maybe 8% performance improvement over not doing anything at all. I think this is pretty good. Now, for GC, you also get options with native image, but if we are talking about peak throughput and optimizing for that specifically, I do recommend that you try out G1 GC. Most likely, it will give you more peak throughput than, for example, serial GC. And then the last flag here is that native image produces always a platform-specific native executable. So let's say out of the box, I cannot compile on my Mac for my Linux cloud instance. But still, with this last flag, you can specify to optimize the binary specifically for this configuration of machine and this specific hardware features to squeeze the most out of this machine and sort of prioritize performance over compatibility across this range of machines. Now, this will be maybe the last second to take a photo if you want to kind of take a note of performance optimizations. And with all the chit-chatting, let's look at the benchmarks. So our JVM was at 1.4K requests per second. Native image out of the box was at 1.1. And native image with all the optimizations that I have mentioned on the slide arrived at 1.5, almost 1.6. Now, I need to tell you here this big legal disclaimer to not take benchmarks seriously and always try on your own application, and those are just reference numbers, etc. But I hope this conveys the point that if you apply additional optimizations, you can get a much faster net executable at runtime, and you can arrive at performance that is comparable with the JVM at runtime. But there is one last sort of point and lesson learned from this benchmark. So as we were running the benchmarks, we were also collecting, OK, this is a lot of files. We were also collecting information about the resources consumption of our application. So let's look at the charts. Let's just open all three side by side. So this is not performance anymore. This is resources consumption. So each benchmark ran with the tool called PS record attached. And this shows us how much CPU was consumed as our application ran and also how much memory was used. And the way to read this is the vertical red lines, that is CPU usage, and the horizontal blue line, that is memory usage. And all three applications ran with the same memory settings, but you can say that even despite that, memory usage is quite different from one to another benchmark. So let's look deeper into this. One thing, remember how I said that we gave the JVM 10 seconds to start, because it does need to do some kind of housekeeping work in the beginning. So indeed, we see that it's quite busy for 5 seconds, but just to be safe, we gave it 10 seconds. And then as the load comes in, as we get more and more requests, JVM sees the need to further optimize the application and apply more work and use more resources to make sure that you have good peak throughput. And the memory, I would say, here results in maybe 700 max for the process. Now, native image out of the box, the one that was somewhat slower, you see that indeed in the first 10 seconds, there was no waste in CPU. The application just started, and it was ready to go, but we didn't send any request yet. And the memory usage here is, I would say, very low, like around 3x less than the JVM. And it differs depending on the application, but I would say in general, you can expect that you can get 3x less memory by running your application as a native image as opposed to the JVM. And then the last one, the one that was also very fast and comparable to the JVM, memory usage here is a bit more, but still less than the JVM. And that memory usage here primarily comes from the G1 GC. So in general, it is kind of an agreement that if you give more memory, you can sort of expect more throughput, or if you want more throughput, you need to kind of sacrifice something, and in this case, it is memory. But it is still less than we would have spent on the JVM. So this was about benchmarking and performance optimizations. And going back to slides, one quick thing that I want to mention when it comes to sort of resources usage. So lately, we see a lot of interest from our users in this sort of green Java, green tech angle of native image. And that is because along with less CPU and less memory, we also use less sort of electricity and any other resources, because again, we don't need to do as much work at runtime as the JVM does. So if you happen to be working maybe in a domain where the government or whatever requires from you to make your applications greener, or show how you care about the environment, and what do you do to implement some green policies, native image, you can see that even under the load, it uses, I would say here on average, maybe 30% less than the JVM still under the load. Now, here we have two more things that we can talk about. I'm wondering if we can talk about it all. So if you were to choose between a security, where we talk about how native image applications are in a way more secure than the JVM, or polyglot, where we mix Java and other languages, what do you want to choose? So security? Not many people care about security, not even Brian, oh my God. OK, then I assume you want to talk about Python. I don't know what happened there, but OK. Let's talk about Python. So we all know and love Java. I hope so. But sometimes there exists this one library, let's say in Python or in JavaScript, that we would like to use. But it's not always so easy to marry that Java or JavaScript or Python code with our Java application. There are ways to do it, but it's kind of cumbersome. It's hard to debug. It's not very fast. And even the whole setup and experience, it's not so good. So here, I would like to talk a bit about how GraalVM can help you with that. And GraalVM can execute many other languages. So we saw on the slides languages like Ruby, JavaScript, Python. But what's funny enough, we give you an API so that if you want, you can write your own implementation of some language on Java. Let's say you are a big fan of Lua, or if you're a big fan of PHP, so you can write your own implementation using our APIs, and in something to like 3 to 6 months, you can have your own implementation, name it after yourself, run it very fast on the JVM. But talking about the languages that we have implemented as a team, I would like to show you this one demo, and maybe we can first take a look at it. So this is called GraalPy Micronaut PyGal charts. So you can see that here we are switching to Micronaut as our framework, and also we will be using some Python in this application. So let's see what's inside. Interesting enough, so far this looks like a normal Java Micronaut project, right? So we have our source main Java, we have our resources, we have our POM.xml. It looks very normal so far. Now, when we look inside, this is where things start to get more interesting. So this is our main application class. Again, perfectly normal so far. Here we define our PyGal service that will have different implementations. And for example, let's look at how we can implement things in Python. So the application that we will be looking at is a Micronaut application that exposes an endpoint. And at that endpoint, hopefully, we'll see a beautiful chart that is coming from the Python, and namely the PyGal library that is very cool for doing this sort of data and ML and visualization sort of things. And again, with GraalVM, you can choose, and here it gets a bit crazy, of how much you want to implement in your Java. For example, you can have most of your logic defined in Java. You just import that PyGal package from Python, but you program most of your logic in Java. Or if you want to mix things up, you can do pure Python, where you only use Java to create your endpoint, and then all the rest of the logic, especially around that chart, is implemented in Python. So here we are importing PyGal and adding some data, and hopefully we will get a chart out of it. Let's see how it works. So again, it is already compiled as a native executable. Right, the best thing is that normally most of our kind of users and customers who do this extending Java with other languages, they run it on the JVM. So you have your program running on the JVM, GraalVM is your JVM, and then GraalVM also executes that Python or JavaScript or whatever code and makes sure that everything is very fast and the interop is good and makes sense. But you can go one step further, and you can compile that whole thing of Java and Python to native executable. And I did this here because I love native image. So this is what we will run, will be a native program. And the thing here will be that the Java part will be compiled to native executable, but Python, it's not something that is so trivial to ahead of time compile. So Python, in this case, will be still dynamically executed, interpreted at runtime. So this gets a bit crazy. I'm sorry for that, but you guys chose Python over security, so this is what you get. Let's run the program. It starts. We see that this is a micronode program. It starts a bit longer, but it also spawns for us this sort of Python context. And then when we go to our application, we see this sort of beautiful, I guess you can say, cosine chart visualization. I don't know if many people in the room are sort of fans of charts and math. I'm not one of them, but you got to give it to that. It is sort of beautiful, and it's even interactive, where you can see for each of the data points values, and you have our legend. And this is something that probably makes the most sense to implement if you want to use Python from Java, because in Python you get the most of libraries for this sort of data processing and visualization things. So I hope this didn't look too scary, but if you want to extend your Java application with other languages, this is something where we see a lot of interest in GraalVM. Just a few recent cases where I can think of how people actually use this in production, as crazy as it sounds. There is a very nice talk from our friends at Picnic, the Dutch company, where they expand their business application. The application is in Java, but they give their business analysts a way to define sort of business logic rules in JavaScript and Python, because those kind of data analyst teams are more familiar with JavaScript and Python, and they can much more easily and faster iterate, because they can very easily define those rules for business logic, such as, I don't know, give a gift, recommend those goods, etc. Those are defined in Python, and then the system picks up that Python logic and embeds in the Java application. They don't need to go and ask the Java team, can you please implement this or that rule for us in Java? So as crazy as it looks, it actually does have good use case and kind of scenarios and benefits in real life. So those were the main things that I wanted to show. I will not stop on the security demo because we are limited in time, but I do want to at least briefly mention for your consideration how native image does that security, adds that security angle to normal Java programs. So we took the native image compiles the application ahead of time into a native executable, and in the end, it doesn't need a JVM to run. It's a fully native program, right? But one thing that we didn't cover yet is that native image, as it compiles the application, it strips away everything that you don't use. So for example, I import some package, and from that package, I use maybe, I don't know, 3, 5 classes, and from those, I use very few methods. So native image, as it compiles your application, it will strip away everything that you don't use. So in that native executable, there will be only the code that has been defined as reached as we analyze your application, and only the things that you need will be in that native executable. Everything else will be stripped away. And this applies to your user code, to your dependencies, your libraries, but also even to the JDK itself. So we are reducing the attack surface because we are stripping away everything that you don't need. Now, we also are, in a way, safer when it comes to reflection and serialization and deserialization, because those things, they do work in GraalVM and in native image, but they require a specific allowed list. So if you want to do anything around reflection, serialization, GNI, proxies, etc., you need to tell us, or your library framework needs to tell us, please make those and those things possible in native image, otherwise they will not work. And this can seem sort of like an extra work, but also it gives you more awareness and more control over what is happening in your application, and neither of those aspects can be exposed without you specifically allowing them. Then we also don't have a JIT compiler anymore. It's all ALT compiled, so there are maybe not that many, but a few attack vectors that target the JIT compiler specifically, and those are just not possible because there is no JIT compiler and no dynamic code execution anymore. And also, we have very nice support for SBOM, so you can always see what's inside your native executable. You can scan it with your vulnerability scanners, and that will tell you exactly what's in your native executable. Now, normally here I talk about the latest release of GraalVM and what came up in that release, but we are already preparing for the next release of GraalVM in September. So you might know that in September, we are all getting Java 25. We are all excited and waiting for it. But also on the same day when you will get Java 25, you will also get GraalVM for JDK 25. And I want to give you a very quick preview of some of the features, not all, but some of the features that will be in that release. So first of all, you will get Java 25 features. If I can suggest, if you want to move to Java 25, you can just download GraalVM for JDK 25, and this way you get all the latest Java features and all the latest GraalVM features in one distribution. I briefly mentioned that we have this sort of ML inference for profiles of your application, where we can look at your application and try to predict where it makes sense to optimize your application. So we are constantly reworking that feature. And then in autumn, we are planning to ship a new edition of this feature where your applications will be even faster out of the box. I don't want to give specific numbers now, but even without doing this two-step PGO process, your applications will be faster when you move to GraalVM for JDK 25. Now, one feature that looks very humble on this slide, but I think might be very impactful and useful for many users of GraalVM will be this age preserve, and namely age preserve all. So I mentioned, again, briefly, that GraalVM strips away everything that you don't need. So only the things that you're actually using will be in your application. And this is good because your application starts fast, it is more secure, but sometimes it also poses a challenge to our users because sometimes there might be older libraries that are not compatible with GraalVM yet. And if we strip away something in that library that we don't think is important, but it is important, that might cause issues. So normally, this is solved by configuration, but not all libraries have added it yet. So the way we want to approach this is we want to give you a flag, which is age preserved, and then you can specify either on the project level, or package level, or module level, what you want to preserve completely in your application. Sometimes we get those requests from users that are very unexpected when they tell us, can I compile my complete app? I don't want to strip away anything at all. I just want to compile everything there is. I don't care how big it will be. Just give me a complete application compiled. With this flag, you will be able to compile either your complete project, or you can specify that I think this library and this package is problematic. Can you please include for me that library completely? Because if that library breaks, this could be a way to include it completely and not hit any issues. Now, the Llama application that I have showed using the Vector API and FFM API, I like the demo a lot because it shows how we support later Java APIs. And now this also comes to more platforms. So this will be in GraalVM for JDK 25. And I cannot give specific details, but we are working on new security features in native image, so stay tuned. All of that arriving in September, and there will be many, many more things. OK, so hopefully I got at least some of you interested, and this is something you want to try out and you want to get started. So those are all the links that you need to know and all the places for you to get started. The first link, this is our website. You can get our docs, downloads. You can pull container images. And if you happen to be an SDKman user, as you should, you can always get the latest builds of GraalVM for SDKman. This is also the way how I usually get my builds. And all the demos, links, etc., that I have showed to you today are on GitHub already. You can scan the QR code and find them. And if you have any questions to me, I will be at the conference the whole day and tomorrow. But also, you can come and talk to me here at the stage. Thank you so much.